Welcome back to those of you that have seen other videos. In this one, we're going to focus on one-dimensional kinematics or 1D kinematics in terms of free fall. So in another video we did a simple 1D kinematic example that was in the X direction. It was this car driving down the road. In this example, if you can read my handwriting, we have an elevator that is currently descending its shaft at a rate of 0.7 meters per second. A mechanical failure occurs and the elevator begins to free fall. If it falls 30 meters before hitting the ground, how long was it falling? And by long, I mean time-wise. So as you can see, this one already is a little different from the car one. It's the same principle. We're going to use the same formulas. If you have those formulas, great. If not, I'll write down the ones that pertain to our problem as they arise, as the need arises. There are three formulas. If you go to UNC and that's why you're watching this video, your professor should probably provide them for you. I've memorized them, but that's because I've tutored physics for almost 2 years. So, I am a bit of an outlier in the fact that I've memorized them. So, we're going to do, the first thing we're going to do for every physics problem is we're going to draw a picture of what's happening. So we have an elevator and he's traveling down at 0.7 meters per second. Okay? And then he begins to free fall for 30 meters and then splats onto the ground right here at 0 meters per second because when it hits the ground, it stops moving. Okay? This is a bit of a simplified version. Normally, there is some kind of impact velocity. We can actually find that real quick. Let's see. I'm trying to think if I should give us a number or if we can solve for a number. I'm thinking we, where's my sheet of paper? Okay, I'm thinking I give us a final velocity. So let's say it hits the ground actually, no, we're gonna find it. So, and then we're gonna also have a part B for okay, we've done this backwards. So this right here, what is its impact velocity? That's what we're gonna look for first. What is its impact? I think I spelled impact wrong, but okay, whatever. Velocity. Okay, so we don't know what this is, and we don't know how long it takes for this to occur. Okay? But because it is in free fall, we know the acceleration. Okay? Acceleration in the y direction is always going to be 9.81. And usually it's negative because I didn't draw them. I'll draw them real quick. According to our coordinates, positive y is up and acceleration is making us fall down. Okay? That's how we think normally. I have this trick to it that is, if A is in the direction of your velocity, so A is going this way, if A is in the direction of your velocity, it is positive, and if A is going the opposite direction of your velocity, it is negative. Now that kind of only works in the realm of kinematics. I mean, I have never tried it in other scenarios, but in kinematics, that's kind of how I think. So so our accelerations and our velocities are going the same direction. So in our case, A is positive. Okay. with, oh, and this is meters per second squared. Okay, where did this happens sometimes. I need to get a little glove. So meters per second squared. Okay. So this is everything that we know, and this is in meters. Okay. So the first thing we are looking for is its impact velocity, or its final velocity. And if we look at our kinematics, we could either use the first one, so I'm going to write that down, Vf equals Vi plus A delta T, or we can use the third one, Vf squared equals Vi squared plus 2A delta S. We can use either one of those. However, if we use the first one, we aren't going to get a number, we're going to get a formula because we have two unknowns. So for part A, we are going to use the third equation, and it's the second one that I've written down, but it's the third equation. Overall, there's one that, at least in my table, there is one between these two that I didn't bother writing down because it doesn't pertain to anything that we're doing right now. So I'm just going to erase this guy, and we're going to use the bottom one. So our final velocity is unknown, so we're going to leave it like that, and our initial velocity is 0.7 meters per second squared plus 2 times 9 point, okay, I don't need to put that in a fraction, I don't know why I was doing that, 9.81 meters per second squared multiplied by 30 meters. Now, if we had kept 9.81 as a negative number, you know, as I was saying, normally it's like you could do it the quote unquote, you know, proper way where A is negative because it's going down and positive Y is up. You could do that, and our 30 then would be final, so it's delta S. So delta S equals, that's final minus initial, which would be our final is 0 and our initial is 30 meters above the ground. So like these are meters above the ground, which would have made this become a negative 30, and this would be a negative 9.81. Either way, you'll get the same answer. It's just if you decide to go with the positive direction is up and your A, since it's going down, is negative, if you decide to go that route, you will have to use this. You will have to do that. My method, you don't have to worry about that. So it's up to you. I don't really know. I don't know if it's enforced, especially for kinematics. Later on, when you get to forces and stuff, the negative sign for the 9.81 will be very important. But for here, it's not really. As long as your directions and signs are consistent throughout. Okay, so next we're just gonna plug all of this formula into our calculator and square root it to get what VF equals by itself. So we have 0.7 squared plus 2 times 9.81 times 30, and all of that is square rooted. So we get 24, oh, okay, yes, okay. 24.27 meters per second. Okay. And that is our answer. So our impact velocity is 24.27 meters per second, which is quite large, quite a bit larger than the 0.7 meters per second the elevator was going before it started falling. And it accelerated quite a lot while in free fall. I mean, it accelerated at a constant rate, but acceleration is the change in velocity, so it accelerated really quickly. In 30 feet, it went from 0.7 to 24 meters per second. Crazy. Next, we're going to find how long that took. So part B is how much time did it take? So this one is going to deal with that kinematic equation that I had erased, where it's VF equals VI plus, oh goodness, A delta T. Okay, and we found our VF. So this becomes 24.27 equals 0.7 plus 9.81 times delta T. Okay, so we just subtract that 0.7 from the 24.27, and we get 23.57 equals 9.81 delta T. So now we just divide by 9.81, and we get T equals 2.4 seconds. So this whole scenario, in 2.5 seconds, the elevator went from 0.7 meters per second to 24 meters per second, which is quite a lot in not a lot of time and not a lot of distance, but that's free fall for you. Now, everything that, is happening in this situation, the same thing applies if your object is smaller or has less mass than the elevator, or maybe it has more mass than the elevator. Who knows? Whenever something's in free fall, mass doesn't matter. And you can kind of think back to the whole in a vacuum does a feather fall slower than a bowling ball? And they fall at the same rate. Same thing here. We're treating everything like this in a vacuum, and there's no resistance because this thing's falling through some wind and all that. All of that is way beyond Physics 1, and we're just doing the most basic applications. I hope this was helpful to you. If it was, feel free to leave me a comment. If it wasn't, feel free to leave me a comment about that too. I would say the most important thing to take away from this, if you only remember one thing from this video, remember what A equals, because kinematics, it's hard to wrap your mind around, especially when it's the first time you've ever seen it, but it is one unit, or one module, I guess. But this right here, this will follow you through the rest of your STEM career, unless you're like biology. But that A value, super important. I hope this helped you. Feel free to leave comments about other topics you want me to cover. I also do some civil engineering stuff. And I could probably do some math too if you were so inclined, And I hope you watch the next video as well.